So in this video, we will be solving O-Level Mathematics, Paper 2, Variant 2 for May-June 2020. So let's start. Question number 1 is, Stefan had an annual income of $21,500 in 2018. His annual income increased to $22,790 in 2019. Calculate the percentage increase. So to find the percentage increase, first we will calculate the increase in salary from 2018 to 2019. So the increase will be 22,790 minus 21,500. 22,790 minus 21,500. So this is $1,290. So the percentage increase will be percentage increase equals to the increase in salary, which is 1,290, divided by the initial salary in 2018, which was 21,500, and then multiplied by 100. So 1290 divided by 21,500 multiplied by 100. So this is 6%. So the percentage increase in salary is 6%. Part B is Stefan invests $1,260 in a bank. The bank pays simple interest at a rate of 2.5% per year. Calculate the amount Stefan has in the bank at the end of 3 years. So since this is simple interest, we will first calculate the amount of interest he would earn in these 3 years. So interest I will be given by, so it's simple interest. So you've studied the formula, which is PRT over 100. P is the principal investment, R is the rate, and T is the time. So principal investment is $1,260 multiplied by your rate is 2.5, and time in years is 3 years over 100. And then divided by 100. So the interest earned is $94.50, 94.50. So we have to calculate the amount in the bank at the end of 3 years. So amount in bank after 3 years will be the initial deposit, which was 1,260, plus the interest earned in those 3 years, which is $94.50. So 1260 plus 94.50. So this is $1,354.50. So this will be your final answer. 1354.50. Part C is Stefan changes 4,300 Indian rupees into dollars. The exchange rate is given. Work out how much he receives. Give your answer correct to the nearest dollars. So you have dollars ratio Indian rupees INR. $1 is how much? 67.8. And Stefan changes 4,300 into dollars. So let's call them X dollars. So we can easily calculate these. These are directly proportional. So more dollars you have, if you convert them into rupees, you will get more rupees. If you have less dollars, if you convert them into rupees, you will get less rupees as well. So for directly proportional, we cross multiply like this to form our equation. So this will be 67.8x equals to 4,300. And x will be 4,300 divided by 67.8. 4,300 divided by 67.8. So this is $63.42 that Stefan will get when he converts 4,300 Indian rupees. You have to calculate the answer correct to the nearest dollar. So correct to the nearest dollar, this will be 63. Since this is 4, so I will round it down to $63. So your answer here will be 63. Question number 2, part A is the length of a rectangle is 6 centimeter more than its width W centimeter. The perimeter of the rectangle is 37. Form an equation in W and solve it to find the width of the rectangle. So if you have this rectangle here, your width is W and your length is 6 centimeter more than its width. So 6 centimeter more means your width W plus 6. And then you're given the perimeter. So we know that perimeter is 2 into length plus width is equals to your perimeter of the rectangle. So I can substitute the values here. Your length is W plus 6 and your width is W. So plus W. So this was capital W for width. This is small w, which is the variable that we are given here. And perimeter is 37. So this will be 2 into 2w plus 6 equals to 37. Now if I open the bracket, I get 4w plus 12 equals to 37. So 4w will be 37 minus 12, which is 25. And w will be 25 divided by 4. So which is 6.25 centimeters. So your width W is 6.25 centimeters. Part B is a rectangle 20 centimeter by 8 centimeter is cut from a rectangle which is 28 by 15. Each measurement is given to the nearest centimeter. So that means to the nearest 1 centimeter. So your error in these measurements will be the degree of accuracy, which is 1 centimeter divided by 2. So your error is 0.5 centimeter in these values of length and widths. So you have to find the upper bound for the area of the shaded region. So this is your shaded region and you have to find the upper bound for the area of the shaded region. So let's first formulate what will be the area of shaded region. So area of shaded region is the area of this big rectangle minus the area of this small rectangle. This will give you the area of the shaded region. So area of big rectangle minus area of small rectangle. Now you have to find the upper bound of the shaded area of the shaded region. So upper bound area, this is U. So upper bound area of shaded region. So what will be the upper bound? So since our shaded area is area of this big rectangle minus area of small rectangle, that means I have this value here, which is the area of big rectangle, and I'm subtracting the area of small rectangle. So how can I maximize this value? I can maximize this if I take the maximum possible area of big rectangle and if I take the minimum possible area of small rectangle. That's when this subtraction will give me the largest possible answer. So that means if I want to maximize this area of large rectangle, I need to increase this width. That means find the upper bound of this width and also increase the length of this rectangle so that I can maximize this area of this big rectangle. And then since I'm subtracting this out of the big rectangle, I need to make this as small as possible, right? So to make this smaller, I will shrink or decrease the width to make it smaller like this, and then, or sorry, length like this, and then I will decrease the width value as well to make this slightly smaller. So this will be the smaller version of this inner rectangle. So how can I decrease the length and width? I will take the lower bound for this 20 and lower bound for this 8 as well. So this is 8 and this is 20. So to increase the area of this outer bigger rectangle, I will take, so area is 28 times 15, but I will add the error values here. 28 times 15 is 100. 100 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 times to take the upper bound of both the length and the width. So area of big rectangle or the upper bound area of big rectangle. So let me first write down. So upper bound for area of shaded region will be upper bound area of big rectangle. So the maximum possible area of the outer bigger rectangle minus the lower bound. So I want to remove the smallest possible area so that my shaded area is large. So bound of lower bound area lower bound area of small rectangle. That's how I will get the upper bound for area of the shaded region. So to find the upper bound area of big rectangle, my length will be 28.5. I will add the error value to take the upper bound of length. Similarly, I will add the error value to take the upper bound of width for this larger rectangle, and then minus lower bound width length will be 19.5. So 20 minus 0.5, and then 8 minus 0.5 will be 7.5. So length into the lower bound for the width. So now this will be the largest possible area of the bigger rectangle, and this will be the smallest possible area of the inner smaller rectangle. So let's calculate this. 28.5 into 15.5. So this is 441.75 minus 19.5 into 7.5. 146.25. So 441.75 minus 146.25. So this is 295.5 centimeter square, the upper bound area of the shaded region. Question number 3. A light L is fixed on a building 8 meter above the base B of the building. So this angle is 90 degree. A point P is on the horizontal ground 12 meters from B. Calculate the angle of elevation of L from P. So this will be your angle of elevation of L from P. So if I take this triangle LPB, it is a right angle triangle. I know the perpendicular height. I also know the base length. So I can use tan of LPB. LPB is the angle of elevation. LPB equals to LB over PB. LB is 8, PB is 12, and LPB will be, so I will 8 divided by 12 and then take the tan inverse of this. So this is 33.69, and then up till 1 decimal place this will be 33.7 degrees, your angle of elevation. Part B is the ladder is placed on the ground at Q to reach the light L. The ladder makes an angle of 70 degree with the ground. Calculate QL. So again, if I look at this triangle QLB, it is a right angle triangle. I know the perpendicular height. I need to find QL, which is the hypotenuse. So this time I will take the sine. Sine of angle LQB will equal the perpendicular height, which is LB, divided by the hypotenuse, which is QL. So if I make QL the subject of this equation, I will bring this here in the denominator and take QL here. So QL will be equal to LB over sine of LQB. So LB is 8 over sine of LQB angle is 70 degrees. So 8 divided by sine of 70. So this is 8.51 up till 3 significant figures. So your length QL is 8.51 meters. Part C is a vertical pole RS of length 1.6 meter is placed touching the horizontal ground. The light produces a shadow TS of the pole on the horizontal ground. LRT, this is a straight line, and TB is 6.5 meters. Calculate TS. So TS is this length that we need to calculate. So if you look at, there are these two triangles RST and LBT. They have this common angle. So let me draw these separately so that it's easier to understand. So this is the smaller triangle. This is RTS. This is 1.6. And then this larger triangle here. So let me draw this as well. So this is LTB. So TB is 6.5. And you also know LB is 8. This is right angle. And since this pole is vertical, this RS pole is vertical, that means this is also 90 degrees. So this is also 90. And this is the common angle between the two triangles, which is equal. So I can easily find this angle using trigonometry. So this is perpendicular height. This is the base. So I can use tan here, tan of angle LTB, to calculate this angle. So once I know this angle here will be the same. I know this height of this triangle. I can easily find TS again using the tan. So let me show you. So first, using this larger triangle, tan of LTB will equal the perpendicular, which is LB, divided by base, which is TB. So this is LB is 8, TB is 6.5. So LTB angle will be tan inverse of this. So 8 divided by 6.5, and then tan inverse of this. So this is 50.9 degrees up till 1 decimal place. So this angle here is 50.9 degree, which is the same as this angle, 50.9 degree. So this one here is 50.9 degree. So I know this angle here, which is this one. I know the perpendicular height of this small triangle RTS, so I can easily find TS. So again, tan of RTS angle, RTS, equals to perpendicular, which is RS, over base, which is TS. So now if I make TS the subject of this equation, I'll take it here in the numerator, and this tan RTS will come down here. So TS will be RS over tan of RTS. So RS is 1.6, and tan of RTS angle is 50.9 degrees. So 1.6 divided by tan of 50.9. So this gives you TS equals to 1.3. TS equals to 1.3 meters. So that's how you will calculate this length TS. Question number 4 is, the table summarizes the time, M hours, that each student in a year group spent listening to music in one day. Some of the results are shown in the histogram. So you have 0 to 1 hours, frequency 8. That means 8 uh, students listen to music for a time between 0 and 1 hours. 10 students listened between 1 to 1.5 hours. P students listened to 1.5 to 2 hours, and so on. So this is the histogram that is partially drawn. So the first part is, use the histogram to find the value of P. So P is your frequency for this class width, which is 1.5 to 2 hours. So if you look at the histogram, 1.5 to 2 hours, your frequency density on the y-axis is 30 here. So we know that frequency density is equals to the frequency divided by the class width. So now if I substitute the values here for this class interval, which is 1.5 to 2 hours. So what is the class width here? Class width here is 2 minus 1.5, one and a half. Class width for this one is 2 minus 1.5, which is 0.5. So frequency density is 30. So 30 equals to the frequency is P that we need to calculate here. P and over class width is 0.5 that we just calculated. So P will be 30 into 0.5, which is 15. So your value of P here is 15. The next part is complete the histogram. So to complete the histogram, I will need to add another column here, which is for frequency density, because we have frequency density on the y-axis of the histogram. So frequency density, which is basically frequency divided by class width. So let me extend this table here. So this will be your frequency density. So your frequency here is 8. In fact, we don't need to calculate the first three. They are already drawn. So you have to worry about only the classes above 2. So I will start with this one. So here your frequency is 14 divided by your class width here is 2.5 minus 2, which is 0.5. So 14 divided by 0.5 will give you 28. 23 divided by class width 1. So 23 divided by 1 will be 23. 18 divided by, so 5 minus 3.5 is 1.5. So 18 divided by your class width 1.5 is 12. And here the class width is 2. So 12 divided by 2 will be 6 here. So now we can complete the histogram here. So 2 to 2.5, your frequency density is 28. So 28 will be this value here and then up till 2.5. And then 2.5 to 3.5, your frequency density is 23. So this is 25, 24, 23 will be this. And then you have to go up till 3.5. And then the next one is 3.5 to 5, your frequency density is 12. So 3.5 to 5 and 12 will be this. And you go up till 5. And then the last one, 5 to 7, your frequency density is 6. So 6 will be this one here. So that's how you will complete your histogram. Part B is the table summarizes the time, C hours that each student in a group of 50 students spent cooking in 1 week. So 8 students spent between 0 and 2 hours, 16 students spent between 2 and 4 hours, and so on. First part is calculate an estimate of the mean time spent cooking. So since you have class intervals here, to calculate the mean, you first need to find the mid values for these class intervals. So let me write down mid values and let's call them X. So I will extend this table here to the right. So this will be your mid values. Then I will add another column here, which will be the product of mid values with frequency. So let's call frequency f, and then here I will write f times x. So what are the mid values here for these class intervals? So here your interval is 0 to 2. The mid value is 1. 2 plus 0, which is 2, divided by 2, 1. 4 plus 2 is 6. 6 divided by 2, you get 3. 6 plus 4 is 10. 10 divided by 2, you get 5, the mid value. This is 14, and then you get 7. And here you have 18 divided by 2, which is 9. So 1, 3, 5, 7, 9. And then you calculate the products. You multiply the frequency with the mid value that you just calculated. So 8 times 1 is 8. 16 times 3 is 48. 15 multiplied by 5 is 75. 7 times 7 is 49. And 4 times 9 is 36. So this is 49 and 36. So now your mean value will be sigma fx divided by sigma f. So basically you add up all these products, so which is 8 plus 48 plus 75 plus 49 plus 36 divided by the sum of all your frequencies, which you know is 50, because there are 50 students in this for table. So the data here given is for 50 students. So let's all add up all these. 8 plus 48 plus 75 plus 49 plus 36. So this is 216 divided by 50. So divided by 50. So your mean value here is 4.32 hours. So 4.32. The next part is draw the cumulative frequency diagram. So you have cumulative frequency on y-axis and time in hours on the x-axis. So now to draw the cumulative frequency curve, I need to add another column here for cumulative frequency. So let me just extend this by here now. So cumulative frequency is the sum of all frequencies up till that point. So this is 8. Then 16 plus 8 is 24. 15 plus 24 is 39. 7 plus 39 is 46. 4 plus 46 is 50. So now you have the cumulative frequency values, and on the x-axis you have hours. So since you have class intervals here, you take these upper bound values for the class intervals when you draw the cumulative frequency curve. So when your x value in hours is 2, your cumulative frequency value is 8. So let's plot these. So 2 and 8 will be this point. The next point will be 4 and 24. So 4 and 24 will be this. Then you have 6 and 39. So 6 and 39 will be this. 8 and 46. 8 and 46. Then 10 and 50, which will be this. So now I will try to join them through a smooth curve. So this will be your cumulative frequency curve. The next part is use the cumulative frequency diagram to find an estimate for the median. So for the median, you first need to find the 50% of total frequency. 50% of total frequency will be 50% is 50 over 100, and your total frequency here is 50. You have 50 students in total. So into 50. So this is 1 by 2 into 50, which is 25. So now you have to find the value in hours when your cumulative frequency is 25. This will give you the median value. So if I draw a straight line, so this is my cumulative frequency value 25. So if I draw a straight line to the curve, and this is up till this point, so this is in the middle of this small block here. So it's kind of in the middle here. So each small block here represents a value of 0.2, because there are 10 blocks here and the value here changes by 2. So 2 divided by 10 is 0.2. So this is 4 and 4.2. So this is in the middle here. So this value here will be 4.1 hours. So your median will be 4.1. Question number 5 is solve these simultaneous equations. So you have two equations here. I will use the elimination method to eliminate one of the variables. So I will multiply this equation by 3 and multiply this equation by 4. That will give me 12y and 12y here, and then I can add them together to eliminate the variable y. So let's rewrite these equations. So if I multiply this first one with 3, I will get 6x minus 12y equals to 33. And then if I multiply the second one with 4, I will get 12x plus 12y equals to minus 24. Now if I add these together, 12 plus 6 is 18x, plus 12y minus 12y will be 0, so cancel out. 33 minus 24 will be 9. So x will be 9 over 18, which is 0.5. Now I can substitute the value of x in this equation, which is 2x minus 4y equals to 11. So x is 0.5 minus 4y equals to 11. This will be 1 minus 4y equals to 11. Minus 4y will be equals to 11 minus 1, which is 10. So let me continue here. Minus 4y equals to 10. So y equals to 10 divided by minus 4, which is minus 2.5. So this will be minus 2.5. So x value is 0.5, y value is minus 2.5. Part B is solve the equation 2x square equals to 3 into 8 minus x. Show all your working and give answer correct to 2 decimal place. So let me first open this bracket. So I will get 2x square equals to 8 threes are 24 minus 3x. Now let me bring everything to the left side. So 2x square plus 3x minus 24 equals to 0. So now I can use the quadratic formula to find to solve this quadratic equation and find the values of x. So x would be equals to minus b. So b here is 3. So minus 3 plus minus square root of b square, which is 3 square minus 4 ac. A is 2, c is minus 24 divided by 2 times a, which is 2 here. So this gives you 3 square is 9 minus 4 into 2 into minus 24. So this is square root 201. So minus 3 plus minus square root of 201 divided by 4. So x will be equal to minus 3 plus square root 201 divided by 4, or x equals to minus 3 minus square root of 201 divided by 4. So let's calculate this first. Minus 3 plus square root of 201 and then divide by 4. So this is 2.79 up till 3 significant figures, and this one will be minus 3 minus square root of 201 divided by 4. This is minus 4.29, minus 4.29 up till 3 significant figures. So 2.79 or minus 4.29. Part C is h is inversely proportional to the cube of g. So that means h is directly proportional to 1 over g cube. So if it was directly proportional, I would have written directly proportional to g cube. Since this is inversely proportional, so it becomes directly proportional to 1 over g cube. So that means h equals to some constant k over g cube. Now you're given h is 4.5 when g is 2. So we have to find the formula. So I have to find the value of k here. So h is 4.5 k over g cube. So that will be 2 cube. 2 cube is 8. So let's continue here. 4.5 equals to k divided by 8. So k will be 8 multiplied by 4.5. So 8 multiplied by 4.5 is 36. So your formula for h in terms of g will be h equals to 36 over g cube. The next part is find the value of g when h equals to 32 over 3. So now you know the formula is h equals to 36 over g cube. Now you have to find the value of g when h is 32 over 3. So let's substitute 32 over 3 in place of h equals to 36 over g cube. So now if I cross multiply, I get 32 into g cube, and 3 times equals to 3 into 36. So 3 into 36 is 108. So 32 g cube will be 108. G cube will be 108 divided by 32. So 108 divided by 32 is 3.375. So my value of g will be cube root of, so if this is cube, on the other side it will become cube root of 3.375. So let's take the cube root of 3.375. So this is 1.5. So your value of g when h is 32 by 3, your value of g is 1.5. Question number 6, part A. Two of these cards are chosen at random. They are placed next to each other to give a two-digit number. Find the probability that the two-digit number is less than 30. So you pick two cards and place them next to each other to create a two-digit number here. So if the two-digit number is less than 30, that means that the first card that you choose should be less than 3. So the only option that we have that is less than 3 is 2. So that means the first card should be 2, and then the second card could be anything. It could be 5. 25 is less than 30. 24 would be less than 30. 26 would be less than 30, and 23 would be less than 30 as well. So you don't care what the second card is, as long as the first one that you pick is 2, you are guaranteed that the number, two-digit number that you will get will be less than 30. So what is the probability that first card that you pick is 2? So you have 1, 2, 3, 4, 5 cards, and out of those 5, this one is 2. So only one of the cards is 2. So the probability that you pick 2 is 1 by 5. So the probability that the first card is 2 is 1 by 5. You don't care about the second card. So this will be your final answer, which is the probability of picking the card that is number 2 here. So 1 over 5 will be the probability. Part 2 is list all the possible two-digit numbers that are prime. So again, you have two-digit numbers that you can get when you pick up two cards out of these 5. Now, if you look at this second card, it cannot be 5, because if it's 5, that means the number that you will get is divisible by 5 as well. So it cannot be a prime number. So you cannot have 5 here, you cannot have 2, you cannot have 4, you cannot have 6 here as well, because if you have 2, 4 or 6, it will be an even number which cannot be prime. So that means the only option that is left is that you will have 3 as the second number, and the first number could be anything out of the rest. So let's see what possible combinations do we get uh, in which our second number is 3. So if my second number is 3, I can get 53, I can get 23, I can get 43, and I can get 63. So these are the 4 possible combinations in which your second digit is 3. And let's see which of these 4 numbers are prime numbers. So 53 is prime. It does not have any factors. It's only divisible by 1 and 53 itself. 23 is also prime. 43 is also a prime number. 63 is not a prime number because it is divisible by 3. It was also divisible by 7 and 9. So 63 is not. So the prime numbers that you can get are 23, 53, and 43. The next part is find the probability that the 2-digit number is a multiple of 4. So the cards we have are 5, 2, 4, 6, 3. So 5, 2, 4, 6, and 3. Now you have to find the probability that the 2-digit number is a multiple of 4. So again, I will look at this 2-digit number and see what I need to have in the second card here so that it's divisible by 4. You cannot have 5 here because it won't be divisible by 4. You can have 2, you can have 4, and you can have 6 here. Those could be multiples of 4. And if you have 3 here, this number will not be divisible by 4. So it won't be a multiple of 4. So let's see. Let's start with numbers ending with 2. So numbers ending with 2. So if you have 2 here, you could have 5 with it, 52. If you have 2, you could have 4, 42, 62, and 32. And then you have numbers ending with 4. They could also be multiples of 4. So if you have number ending with 4, you could have 54. You can have 24, 64, and 34. And then you have numbers ending with 6. So you could have 6 as the second. So 56, 26, 46, and 36. Now we can quickly see which of these are divisible by 4. So 52 divided by 4 is 13. So this is divisible by 4. 42 is not. 62 divided by 4 is not. 32 is. 8 fours are 32. So this is a multiple. 54 is not. 24 is. 64 divided by 4. 16. This is the multiple of 4. 34 is not. 56 divided by 4 is 14. So this is also a multiple of 4. 26 is not. 46 is not. 36 is as well. So you have 1, 2, 3, 4, 5, 6. You have 6 numbers that are multiples of 4. 6 out of the total combination of numbers that you can form. So how many total possible combinations you can get of 2-digit numbers? So when you're picking 2 numbers, you have how many options for the first one? 1, 2, 3, 4, 5. So you can pick 5 possible cards for the first one. And then once you have picked the first one, how many are left? If you cancel any one of them, you are left with 4 cards. So for the second card, you have 4 possible options. So 5 times 4 is 20. So you have 20 total possible combinations of 2-digit numbers. And out of those 20, these 6 are multiples of 4. So your probability will be 6 over 20. So if you can't figure out the total possible combinations of these two-digit numbers, you can also draw the table to list out all the possible outcomes. So you have 5, 2, 4, 6, 3 here. And then similarly 5, 2, 4, 6, 3. So you cannot pick the same number twice because you only have one card. So this will be empty here. This is 52, 54, 56, 53, 25, and then this is not possible. You cannot have two of the same numbers. So 24 and so on. So these will be uh, these outcomes are not possible. So there are total 1, 2, 3, 4, 5, 25 boxes. Out of those 25, 5 are not possible because they are same numbers on both sides. So 25 minus 5 will again give you 20 possible combinations of two-digit numbers that you can form using these cards. So out of those 20, 6 of these are multiples of 4. So the probability that the two-digit number that you form is a multiple of 4 is 6 over 20. Part B is Rowan throws a dice 200 times. The bar chart shows his results. So you're given number on dice on the x-axis and the frequency that you get this number on the y-axis here. So use the bar chart to complete the table of results. So number on dice 4, and here your frequency is 35. So this will be 35. For 5 your frequency is 22, and for 6 your frequency is 38. Using Rowan's results, find the relative frequency that he threw a number less than 3. So relative frequency, which is basically the probability uh, that the that number is less than 3. Number is less than 3. So how many total times he threw the dice? 200. So your denominator will be 200. And out of those 200, how many times did he get a number that was less than 3? So how many times did he get? 1 and 2. So he got 1 46 times and he got 2 31 times. So this will be 46 plus 31, which will be 77 over 200. So out of the 200 times he threw the dice, 77 times he got a number that was less than 3. That means 77 times he either got a 1 or a 2. So this will be 77 over 200. Rowan says that the dice he has thrown is not a fair dice. Make 2 comments to explain why the dice may not be fair. So the first comment that you can make is that you have a very large sample size. So the data that he collects is fairly accurate because he threw the dice 200 times. So you can say that the sample size is large, so you can have confidence in your results. And then the second point that you can make is if this was a fair dice, your frequencies would have been equal, or your relative frequencies should be equal, because every number will have the same. Rowan will basically have the same chance of getting the number 1 on the dice, the number 2 on the dice, the number 3 on the dice. So if the dice was fair, all of these frequencies should be equal. So and basically your relative frequency or the probability of getting each of these numbers should be the same. But you can see here the relative frequency to get the number 1 is 46 over 200. So this is your relative frequency. So for this it is 46 over 200. For number 3 you have 28 over 200, and for 5 you have even less, 22 over 200. So you can say The sample size is large and the relative frequency of each number is different. You can also give an example. For example, uh, relative frequency of 1 is 46 over 200, which is much greater than you can say 22 over 200, which is the relative frequency of 5. Relative frequency of 5. So that's why you can say with fair confidence that the dice is not fair. Question number 7, the table shows some values for y equals to 4 power x. So the first part is you have to complete the table. So if x is 0, 4 power 0 will be 1. Anything power 0 is 1. The next is 4 power 0.5, which means 4 power 1 over 2, which is basically the square root of 4, which is 2. The next part is draw the graph of y equals to 4 power x for x between 0 and 3. So you have x on the x-axis and the y values, y equals to 4 power x on the y-axis. So your first point is 0 and 1. So 0 and 1 will be this point here. The next is 0.5 and 2, which will be this point here. 1, 4. 1.5 and 8. 2 and 16 will be this. 2.5 and 32 will be this. And then you have 3 and 64. 3 and 64 will be this point here. So now you have to draw a smooth curve to connect these points. So this is how your curve will look like. The next part is by drawing a tangent, estimate the gradient of curve when x equals to 2. So x equals to 2 is this point. So you will draw a line, a straight line that just touches the this curve at x equals to 2, and the gradient of that line will give you the estimate for the gradient of curve when x equals to 2. So let me bring my ruler here and we'll try to draw a line which will just touch this curve at x equals to 2. Maybe a little bit more. So you'll try to align the ruler such that it just touches the curve at this point. So I think, yeah, that should be good enough. So let me just, all right, now we can draw a straight line here, which will just touch the curve at this point. So this is our line which just touches the curve at x equals to 2. And now we can calculate the gradient by taking any 2 points on this curve. So let's take this x-intercept. So your x value here, this is 1.5. So 2 blocks represents a value change of 0.5. So this is 1.5, 1.4. 1.35. So this is 1.35 and 0. And then we can take this value, which is, so I took this one, and we can take this value when x is 3. Your y value is 40. So we can calculate the gradient here. So gradient m will be y2 minus y1. So 40 minus 0 divided by 3 minus 1.35. 3 minus 1.35. So this would be 40 divided by 3 minus 1.35, which is 1.65. So 40 divided by 1.65 is 24.2 will be your gradient here. So this is within the range given in the marking scheme, which was 18 to 27. So any value between 18 to 27 will be correct for this part. Part 4 is the solutions of the equation 3 into 4 power x plus ax plus b equal to 0 can be found from the points of intersection of y equals to 4 power x and y equals to 20x minus 12. Find the values of a and value of b. So that means if we solve these two equations simultaneously and eliminate the variable y, we will get this equation. So we have y equals to 4 power x and y equals to 20x minus 12. So let me substitute y equals to 4 power x in this equation. So I will get 4 power x instead of y here equals to 20x minus 12. So now I have this equation in x. Now I have to convert it into this form so that I can do the comparison and find the values of a and b. So I have 4 power x and all the values on one side and 0 on the other. So I'll take these values on the left as well. So I will have 4 power x minus 20x plus 12 equals to 0. Then I have this 3 being multiplied with 4 power x. So I will multiply 3 on both sides of the equation. So 3 into 4 power x minus 20x plus 12. 3 times 0 will be 0. Now if I open this bracket, let me continue here. If I open this bracket, I get 3 into 4 power x minus 60x plus 36 equals to 0. Now if I compare these two equations, I have 3 into 4 power x, 3 into 4 power x plus ax. So coefficient of x is a here, coefficient of x here is minus 60. So your value of a is minus 60. The constant value without any variable x is b here. The constant value here is 36. So your value of b is 36. The next part is by drawing the line y equals to 20x minus 12 on the grid opposite, find all the solutions of this equation. So we have to draw this line, so we can take a couple of values of x and y. So we can get 2 points. So if I take x equals to 0 here, my y value will be minus 12, but my y-axis is all in positive. So I cannot take a point where my y value is negative because I won't be able to plot it on this graph. So let's take x equals to 1. So 20 into 1, 20. 20 minus 12 will give me 8. So this point I can plot. And then let's take x equals to 2. So 20 multiplied by 2 minus 12 will give me 40 minus 12, which is 28. So your y value is 28. So your first point is 1 and 8. So let's plot these. 1 and 8 will be this one. And the other point that you have is 2 and 28. So 2 and 28 will be this point here. So now we can join them together with a straight line to have the line for the equation that we have. So this is the equation, the line for y equals to 20x minus 12. So y equals to 20x minus 12. So now we need to find the solutions of this. That means we have to find the x values where this line intersects with the curve. So this is the first point where it intersects. So this is 0.5, 0.6, 0.7, and then 0.75. So here the x value is 0.75, and the other x value is, this is 2.5, 2.6 almost. So this is 2.65, so almost 2.7, just a little bit less. So we can draw the line here in the middle. So this is 2.5, 2.6, 2.65, 2.7. So we can call this 2.655, right in the middle of 2.56. So it is between, this is 2.6, this is 2.7. So this is 2.65, so this is 2.655. So I can round it up to 2.7. So the range given in the marking scheme is 2.65 to 2.7. So 2.655 is also correct. I can round it up to 2.7, which is also in the acceptable range for the answer given in the marking scheme. So the two values of x where the line intersects with the curve is 0.75 and 2.7. So these will be your answers. The next part is, here is a sketch of the graph of a quadratic function. The curve has a maximum point PQ. Find the value of P and value of Q. So P is basically the x coordinate of this point, Q is the y coordinate. So you have studied in the graphs of quadratic equations that this maximum point, if you draw a straight line down like this, it is a line of symmetry. So this curve is symmetrical around this line, which has the equation of this line is x equals to this is value is p. So the x coordinate here is p here. So that means if this is the line of symmetry and I have these two uh, points where the curve intersects the x-axis, so that means this distance is equals to this distance here. So here, so this point here is the midpoint if I draw a straight line from -2 to 4. So what will be the x value of the midpoint? So midpoint here will be -2 plus 4 divided by 2, which is 2 divided by 2, which is 1. So the value of p here is 1. That means this point here on the x-axis is 1. So your value of p equals to 1. And then you have also studied that you can calculate the equation of a quadratic function using the formula y equals to x minus h into x minus k. And this is for a curve that opens upward. So this curve, which is like this. But since we have the curve which is open downwards, the formula changes. I only add a negative sign here into x minus h into x minus k, where h0 and k0 are the x-intercept of this curve. So where does this curve intersect the x-axis? So your value of h here is -2 and the value of k here is 4. Basically, the coordinates where this curve passes through the x-axis. So if I substitute the values here in this equation, I get y equals to minus x. This minus and this minus becomes plus, so y plus x plus 2 and x minus k, which is x minus 4. So y equals to, if I multiply these brackets and keep the negative sign as it is, so I get x square minus 4x plus 2x minus 8. And y equals to minus x square minus 4x plus 2x will be minus 2x and then minus 8. Then if I multiply this negative sign, I get y equals to minus x square plus 2x plus 8. So this is my equation for this curve. So let me write it down here. Y equals to minus x square plus 2x plus 8. You can double check this as well. We know that when x is 0, your y value on the curve is 8. So if I substitute 0 here, this becomes 0, this becomes 0, and you get y equals to 8. And then if you have x equals to minus 2, your y value is 0 here, this coordinate minus 2 and 0. So if I substitute minus 2 here, I get y equals to minus 2 square is 4, and then minus 4, and then 2 into minus 2 is minus 4 plus 8, which is minus 8 plus 8, which is 0. So that is to confirm that this equation is correct. I basically substituted two values of x to find the y values. So if I substitute x equals to 0, I get y equals to 8. And if I substitute x equals to minus 2, I get y equals to 0. So that is correct. So now we have to find this coordinate q here. I know that the x coordinate here p is 1. So I will substitute 1 here. Minus 1 square plus 2 into 1 plus 8. So this will be minus 1 plus 2 plus 8. 8 plus 2, 10. 10 minus 1, 9. So your value of q here is 9. So p is 1 and q is 9. Question number 8 is a birthday cake is in the shape of a cylinder. There are two layers of cake and one layer of icing. Each layer of cake has radius 10 centimeter and height 3 centimeters. So this height is 3, and then there's this layer is of the icing, and there is another layer of cake which is 3 centimeters. So icing, the height of the icing is 12 millimeters. Calculate the volume of icing in the birthday cake, giving your answers in centimeter cube. So volume of icing, if you look at the icing, it is basically this part, which is a cylinder of height 12 millimeter, but you have to give your answer in centimeter cube. So 12 millimeter, I can convert this into centimeter by dividing it by 10. So I will get 1.2 centimeter. So volume of icing will be simply volume of a cylinder, which is pi r square h. So pi into radius throughout is 10 centimeter. You're also given here that the icing has radius 10 and height 12. So 10 square into 1.2 centimeter, which is the height. So pi into 100 into 1.2, which is 376.99. I can write it up till three significant figures as 377 centimeter cube. The next part is the top and the curved surface of the birthday cake are now covered with chocolate. Calculate the area of the birthday cake that is covered with chocolate. So now your curved surface area, which is like this throughout. So the whole curved surface area of this cylinder is covered, and this top portion is covered as well. So basically, you will take the curved surface area of this cylinder and the top surface area and add them together to get the total covered surface area with chocolate. So area covered with chocolate will equal curved surface area plus you can call it the top surface area. So we know that the curved surface area of a cylinder is 2 pi r h. The top of this cylinder is a circle, so the surface area of a circle is pi r square. So I'll substitute the values here. So this will be 2 into pi into radius of this cylinder is 10. Height of this cylinder is this full height, which is 3 centimeter plus 3 centimeter, which is 6. 6 plus 1.2 is 7.2. So your total height of the cylinder is 7.2 centimeter plus pi into r square. So the top is a circle with radius 10, so 10 square. So now let's calculate this. Pi into 2 into 10 into 7.2. So this is 452.389. 452.389 plus pi into 100. So 314.16. So 452.389 plus 314.16 is 766.549. 766.549, and up till three significant figures, this will be 767 centimeters square. So 767 centimeters square will be the total surface area that will be covered with this chocolate. The next part is Anil has a slice of this chocolate covered birthday cake. His slice is a prism of height 7.5. The top of the cake is a sector with radius 10.3 and angle x degree. The volume of this slice is 200 centimeter cube. Calculate the value of x. So we can use the volume, calculate the volume for this slice. The cross section of this prism is a sector. So if I can calculate the area of this sector and multiply it with the height, I will get the volume for this birthday cake, slice of this birthday cake. So let's calculate the volume. Volume of slice will equal the area of sector multiplied by the height of the prism. So volume is given, it is 200. What will be the area of this sector? It will be x over 360 degrees into pi r square into pi into r is the radius of this sector is 10.3. So 10.3 square multiplied by the height of the prism, which is 7.5. So x is the only unknown in this equation. We can calculate that. So let me first calculate this right side. 10.3 square multiplied by 7.5. So I have 200 equals to 795. So 795.675 into pi into x over 360. So my value of x will be, this 360 will be multiplied. So 200 multiplied by 360, and this 795.675 pi will come in the denominator on the other side. So this will be 795.675 pi. So let's calculate this. 200 multiplied by 360, and then this divided by 795 0.675 multiplied by pi. So this is 28.8 degrees up till one decimal place. So this angle x here is 28.8 degrees. Let's move on to the next question. Question number 9 is EMF and GLNH are parallel lines. So these two lines are parallel. This length LM is equals to this length LN, and this angle is 126 degrees. Find angle FMN. Give a reason for each step of your working. So FMN is this angle here. So since these two are parallel lines, FMN and MNL will be equal because these two are alternate angles. And then since these two sides are equal, LMN is an isosceles triangle. So this angle and this angle will be equal as well. So we can easily find this angle here because this is a straight line. And once we know this angle, we can easily find the other angles as well. So let's start with finding this green angle here. So we can say that 126 degrees plus MLN angle will equal 180 degrees because it's an angle on a straight line. So this will give you MLN equals to 180 minus 126, which is 54 degrees. So this angle here is 54. Now we can say that angle LNM, so angle LNM equals to angle LMN because angles, these are angles in isosceles triangle. So we can say that 54 degrees plus 2 times this angle L and M, because this is L and M, this is also equal to L and M, so I'm taking 2 times L and M should equal 180 degrees. Because sum of angles of triangle is 180. So this will give me L and M equals to 180 minus, so 180 minus 54 divided by 2. So 180 minus 54 and then divide by 2. So this is 63 degrees. So this angle is 63, this angle is 63 degree as well. And then we can say that angle L and M, angle L and M equals angle FMN, because these two lines are parallel and these two are alternate angles. So we can say that these are alternate angles. So this will give you FMN equals to 63 degree as well. So this will give you FMN equals to angle LNM, which is 63 degree. So your final answer here will be 63. Part B is A, B, C, D are points on the circumference of a circle with center O. BD and AC intersect at this point E, and BC is the diameter. This angle is x degrees and this angle is y degrees. Find an expression in terms of x and or y for angle DBC. So DBC is this angle here. So if you look at this angle DBC, it is subtended by this arc and it is subtended at the circumference of this circle. So it is subtended like this at the circumference of this circle. And if you look at this angle y, it is also subtended by this same arc DC at the center of this circle. So this angle will be y over 2 because we know that angle at circumference is twice the angle at the, oh sorry, the angle at center is twice the angle at the circumference. So angle DBC will be y over 2 degrees. The next angle we need to find is angle ABD. So let me just erase this. ABD, ABD, ABD is this angle here. So this is subtended by this arc here, which is AD. And if you look at this angle X, it is also subtended by this same arc AD. So we can call them the angles in the same segment or angles subtended by the same arc on the circumference. And we know that these angles are equal. So this angle will be X degrees as well. So angle ABD will be X. The next is angle AED. So let me just erase this. AED is this angle here that we need to calculate. So now if I look at this triangle ECD, this angle is 90 degrees because it is subtended by this diameter. So this is an angle in a semicircle or angle that is subtended by the diameter on the circumference of the circle, and we know that that angle is 90 degrees. So we need to find this angle AED. So if I can calculate this angle here, I know that angle AED plus this red angle will be 180 degrees because this is a straight line. So if I look at this triangle CDE, I know the two angles. So let's call this angle, so angle DEC. So angle DEC plus this angle 90 degrees plus this angle X should equal 180 degrees because these three are angles of this triangle CDE. So this is 180. So this will give you angle DEC will equal 180 minus 90 will be 90 minus X. So this angle here is 90 minus X. So that means angle AED plus this angle 90 minus X should equal 180 degrees because this is an angle on the straight line. So this will give you angle AED equals to 180 minus 90 will be 90, and this will become plus X on the other side. So this is how you will calculate this angle AED, which will be 90 plus X. So let me take it down here. So from this, we got AED equals to 90 plus X. So your angle AED is 90 plus X. The next angle that we need to calculate is angle BDA. So angle BDA is this angle here that we need to calculate. So we know that this angle we just calculated in the previous part, this is 90 plus X. This is the angle that is unknown. And if I look at this triangle AED, I know this angle, I know this angle, and I can calculate this angle easily because this angle is subtended by this arc. So let me mark this in red. So this arc subtends this angle at the center, which is y degrees, and it makes this angle on the circumference. So this angle should be half of y because this is this is at the circumference and this is at the center. So this angle will be y by 2 here. So let's just remove this. So this angle is y by 2, and we need to calculate this angle. So now I know this angle, this angle, this is the only unknown. So using the triangle AED, I can write y by 2, this angle, plus this angle, which is 90 plus X, plus this angle uh, BDA should equal 180 degrees because these three are angles of a triangle. Sum of the interior angles of a triangle should be 180. So now we can solve this equation. So let me bring it down here. So now my angle BDA will be, I'll take the rest of these on the other side of the equation. So 180 minus 90 will be 90. This X will become negative X. This positive Y by 2 will become negative Y by 2. So your angle BDA is 90 minus X minus Y over 2. Next question 10 is you're given the volume of the pyramid ABCD is a rectangular based pyramid. So this base is a rectangle. So that means all of these corners are 90-degree angles. This one is 90, this one is 90, and this one as well. So you're given AC and BD intersect at F. So AC and BD are the two diagonals of this rectangular base. They intersect at this point F. EF is the perpendicular height. So it is perpendicular to this length FC. AD is 10, this length is 6, and this is 12. Show that EF is equals to 10.5 centimeter correct to one decimal place. So EF is this height uh, that we need to show that this is 10.5 centimeter. So if I draw this triangle EFC, let me draw this triangle outside EFC, which is a right angled triangle. So this point is F, this is C, and this is E. So this is the EF side that we need to calculate. The hypotenuse of this triangle is 12. This is a 90-degree angle. So now if I can calculate this length FC, then I can use the Pythagoras theorem to find this height EF. And now to find FC, I will use this triangle ADC, which is the part of the rectangular base. So let me draw this triangle as well. So this is AC, this is 10, this is D, and this is 6. So this angle here is 90-degree. So I can easily calculate this length AC using the Pythagoras theorem because I know this side is 10, this side is 6. So the hypotenuse will be AC. So AC square should equal AD square plus CD square. So AC square will be 10 square plus 6 square. So AC square is 136. 100 plus 36, 136. So AC will be square root of 136, which is 11.66 centimeters. So this full length is 11.6. This side 11.66, 11.66. So FC, which is this length for this triangle, this length FC, let me mark this in red here. So this length FC is half of 11.6. So this is 11.66 divided by 2. So now I can calculate FC here. FC will be AC divided by 2. So 11.66 divided by 2. So this is 5.83. So now I know this length is 5.83, which is this length in this triangle. So if I look at this triangle EFC, it is a right angle triangle. I know the hypotenuse is 12. I know that this side is, let's call this the base. It is 5.83 or 11.66 divided by 2. And EF is the only unknown that we need to show. So now EF square. So I'll use the Pythagoras theorem for this triangle EFC here. So EF square should equal, oh no, sorry, the hypotenuse is EC. So EC square should equal EF square plus FC square. EC square is 12 square, EF is the unknown, and FC is 5.83 square. So now let's calculate this. 12 square minus 5.83 square. So EF square is 110.0111. EF will be the square root of this. So square root of this is 10.4886. So you have to show it up till one decimal place. So this will be 10.5. You will round this up to 10.5 centimeters. So that's how you will show that EF is 10.5. The next part is find the volume of the pyramid. So volume is given as 1 by 3 into base area into height. So 1 by 3 into base area multiplied by the height. So the base area will be the area of this rectangle ABCD. This is a rectangle, the base, and the area for this rectangle will be length multiplied by width. So 10 times 6 multiplied by the height of this pyramid, which is this height EF that we calculated and showed that this is 10.5. So I will multiply this by 10.5. So 1 over 3 multiplied by 10 multiplied by 6 multiplied by 10.5. So this is 210 centimeter cube, your area of this pyramid. The next part is calculate the angle DEC. So let's go back. Let me just erase all of this. So angle DEC is this angle in this triangle DEC. So since this is a pyramid, that means all of these slanting heights are equal. So if this height is 12, this height is 12, ED is 12, AE is 12 as well. So now if I draw this triangle DEC, let me draw this here. So DEC, so this is D, E, and C. This is the angle that we need to find. This side is 12. This side is also 12. So these two sides are equal. And this side DC at the bottom is 6. So let me take this. And now we can use this to find our angle. So now I know uh, 3 sides of this triangle. I want to calculate this angle here. So I can use the cosine rule here. So since this is the angle I need to find, the side opposite this angle is DC. So using the cosine rule, I will write DC square equals to the square of DE square plus CE square minus 2 times DE into CE into cos of this angle DEC. So now let's substitute the values here. DC is 6, so 6 square. This is 12 square plus 12 square minus 2 into 12 into 12 into cos of DEC. So let's calculate this. If I take these 12 squares to the other side, so I have 6 square on the left. This way, these will be subtracted on the other side. So minus 12 square and then minus another 12 square. So this is minus 252 equals to 2 into 12 into 12 minus 288 cos of DEC. So this negative negative cancels out. Cos of DEC will be 252 divided by 288 and DEC will be the cos inverse of this. So let's calculate this. 252 divided by 288 and then cos inverse of this. So this is 28.955, which is 29.0 degrees up till 1 decimal place. So this will be rounded up. If I want to write it up till 1 decimal place, this is 5. So this 9 will be rounded up, which in turn will round this up to 29 as well. So your final answer here will be 29.0 degree up till 1 decimal place. The next part is calculate the area of triangle DEC. So now we know that this angle here is 29 degrees. So I can use the formula for the area. Area will be equals to 1 by 2 into these two sides into DE into CE multiplied by the sine of angle between them, which is DEC, this angle between them, which is 29. So let's substitute the values. DE is 12, CE is also 12, and then sine of 29.0 degree. So 1 over 2 into 12 into 12 into sine of 29. So this area is 34.9 centimeter square up till 3 significant figures. So this will be 34.9 centimeter square. Question number 11, part A, describe fully the single transformation that maps triangle A onto triangle B. So this is clearly not a translation because the orientation of the triangle has changed. It is pointing upwards here and then it's pointing downwards. So it's not a translation. This is also not an enlargement because the size of the triangle remains the same after the transformation. Can it be a rotation 180 degrees like this? So if I rotate this downwards 180 degrees, it will look something like, so this will be rotated like this. So it will look like this after I rotate it 180 degrees. So this hypotenuse is towards the right, but in triangle B, you have it towards the left. So that means this is a reflection. So now to find the line of reflection, I will connect this object vertex with its image. So this vertex is mapped onto this one. So if I connect it like this, what's the midpoint of this line? So this is 1, 2, 3, 4, 5, 6. So the midpoint is after 3. So this is the midpoint. And then if I connect another pair of object with its image, so this vertex is mapped onto this vertex. If I connect them like this as well, and then find the midpoint, again the midpoint is this one. So that means if I connect these two midpoints through a straight line, I will get my line of reflection. So let me draw this in green. So if I join these two with a straight line, the line looks like this. So this line has an equation y equals to -1. So the transformation that will map triangle A onto triangle B is a reflection in the line y equals to -1. So that's how triangle A is mapped onto triangle B. The next part is triangle A is mapped onto triangle C by the single transformation H. Find the matrix representing H. Now there are two ways to solve this. I'll show you both. The first one is using the observation and the second one is using the matrices. So the first one is you'll try to observe and see if you can find what type of transformation will map triangle A onto triangle C. So it looks like a 90-degree rotation like this. If I rotate this triangle 90 degree like this, it will look something like triangle C. So that means there is a rotation 90 degrees in this direction, which is anti-clockwise, which maps triangle A onto triangle C. Now the only thing that we need to find is the center of rotation. So if you cannot figure it out directly from looking at the triangles, we can actually use the line bisectors to find the exact position of the center of rotation. So how do you do that? You connect the object. So this vertex is mapped onto this vertex. So if I connect them through a straight line, oops. So let me actually draw a straight line between them. So then I need to draw a line bisector for this line. So to draw a line bisector, I'll use my compass here, open it more than half the length like this, and then draw an arc on this side. Also draw an arc on the other side. Without changing the length of the compass, place it on the other point, and then draw the arcs on this side and this side. So this will be my line bisector for this line. And then I need to draw another one. Let's draw it in red. So this vertex is mapped onto this vertex. So this will be the line joining the two vertices. And then if I draw the line bisector for this as well, the intersection of the two line bisectors will give me the center of rotation. So you can draw this with pencil, and then once you have found the center of rotation, you can erase this also. I will open this up again more than halfway. So This might go outside the grid, but that's fine because the question doesn't really asks you to draw the line bisectors. So it wouldn't matter if it goes out of the uh, grid as well, because you're going to eventually erase them because you're only concerned with finding the center of rotation. So drawing another arc on this side and then another arc on this side. So it is this arc, I think, yeah, this and this one. So this has the other end is this and this other end is this. So these two intersect at this point. So now I will draw another line bisector, and they're both this green line and red line, the two line bisectors, they intersect at the origin. So your center of rotation is 0, 0. So let me just erase all of this now. And erase this. So now you have found the center of rotation is this point 0, 0. So if I connect this vertex with the center of rotation like this, and then this is mapped onto this, so I'll connect its corresponding image with the center of rotation. You can measure this angle is 90 degree. So this is a so the transformation that maps triangle A onto triangle C is a rotation. So let me just move this out of the way. It's a 90-degree anti-clockwise rotation. Anti-clockwise rotation with center 0, 0. So this is your single transformation H. It is a 90-degree anti-clockwise rotation with center 0, 0. Now to find the matrix which represents this transformation, uh, I can use the trick that you have learned. So you draw the axis and you take 2 points. So the first point you will take is 1, 0, and the second point that you will take is 0, 1. And then you apply the transformation to both these points, and the image will give you the matrix that represents this transformation. So if I rotate point 1, 0, 90-degree anti-clockwise with the center, so if I connect it with the center, 90-degree anti-clockwise will take me to this point. So the image of 1, 0 will be 0, 1. So your first column is 0, 1. And then if I apply this same transformation 90-degree anti-clockwise with center 0, 0 for this point, which is 0, 1, if I connect this with the center, 90-degree anti-clockwise will move this point to this point, which is -1 and 0. So this is -1 and 0, the coordinates of this point. So if I call this A, this will be A dash. If I call this B, this is B dash. So you write down the coordinates of A dash and B dash as column vectors to get the transformation matrix H. So this is the first method, using observation and finding out what exactly is the transformation and then writing down its matrix. The second method is, if you don't want to do all of this, if you cannot find through observation that what type of transformation is this, you can directly use matrices as well. So if you learned that if you apply a transformation to an object O, T times O will give you the image I. So since this is mapping triangle A onto triangle C, let me call this transformation matrix T that we need to find, which is the unknown, as let's call this A, B, C, D. And my object will be, I will take two vertices, coordinates of two vertices of triangle A. So I can take this point, which has coordinates 3, 2. So object is 3, 2, and let's take this one, which has coordinates 4, 2. So, and the image will be the corresponding point. So this 3, 2 is mapped onto this point, which is -2 and 3, and this 4, 2 is mapped onto this point, which is minus 2 and 4. So if I rewrite this equation, my transformation matrix T is A, B, C, D. Object is this 3, 4, 2, 2, and the corresponding image for these points 3, 2 is mapped onto this point, which is minus 2 and 3, minus 2, 3, and this point 4, 2 is mapped onto this point, which is minus 2 and 4. So now I can find this transformation matrix T if I multiply with the inverse of O on this side and inverse of O on this side. This O will cancel out and my T will be equals to OI times, this is I, times O inverse. And so O is this, I need to find the inverse of this matrix. So let's first find, so this is my transformation T multiplied by O equals to image. So I'm looking to find the inverse of O. So determinant of O will be 3 2s are 6 minus 8. 6 minus 8, which is minus 2. So inverse of O will be equals to 1 over determinant, which is minus 1 over 2, multiplied by the adjugate of O. So in adjugate, you swap the places of these two. So this will become 2 and 3. And then you change the sign of the other two. So this will become minus 4 and this will become minus 2. So if I bring this minus 1 by 2 inside, I will get this will become minus 1. This will become plus 2. This will be plus 1. And this will be minus 3 over 2. Let me in fact write it down a little to the left here. This is 0. So this inverse is minus 1, 2, 1, and minus 3 over 2. So this is your inverse of this matrix O. So this will give you T equals to this matrix 2, minus 2, 3, 4 multiplied by O inverse. So I multiplied O inverse here and O inverse here. So this cancels out. I'm left with T, which is ABCD. So if you want, you can write ABCD here as well on the left side, doesn't matter. So 2 minus 2, 3, 4 is this I, and then O inverse is this. So now my first column will be multiplied by the first row. 2 times minus 1 is minus 2, minus 2, and then this plus, so this will be, let me write this down. 2 times minus 1 is minus 2, and then plus minus 2 times 1. Oops, this was minus 2. Minus 2, 3 here. So this is minus 2, 3, minus 2, 4. So minus 2, 3, minus 2, and 4. So minus 2 times minus 1 is actually plus 2. So I'm doing the matrix multiplication here. So this is plus 2 and then minus 2. And then this row multiplied by this column will give me minus 4. And then minus 2 times minus 3 by 2 is plus 3. And then this row multiplied by this column is minus 3 plus 4. This is 3 2s are 6. And this is minus 6. So 2 minus 2 is 0. Minus 4 plus 3 is minus 1. Minus 3 plus 4 is plus 1. 6 minus 6 is 0. So you get the same answer here as well. So you just basically form an equation in these matrices. You find the inverse of this matrix, multiply it on the right side to get the transformation matrix ABCD. So your A value is 0, B value is minus 1, C is 1, and D here is 0. So this is another way if you don't want to, or if you cannot find from observation what type of transformation is this, you can directly use the matrices. So you took two vertices of the object. So object is your triangle A. I chose this vertex, and its corresponding image was this vertex and this vertex. So you applied the transformation on the object to get the image. So using matrix algebra, you took the inverse, multiplied on the other side, and directly calculated this transformation H, the matrix for this transformation H. So let's move on to the next part. Transformation M is a reflection in the line x equals to 2. Transformation R is a rotation 180 degree about 0, 0. Triangle A is mapped onto triangle D such that RM of A equals to D. Draw and label triangle D. So first you apply transformation M on this triangle A, and then whatever triangle you get, you apply this transformation R on this on that triangle. So we have to first apply M. M is a reflection in line x equals to 2. So let me just erase this. So line x equals to 2 is this. So now I have to reflect my triangle A in this line x equals to 2. So this distance is 1, perpendicular distance here is 1. So I'll go the same distance at perpendicular as well, 1. So this will give me this point. This distance is 2 from the line of reflection, perpendicular distance 2. So if I go perpendicular distance 2 on the other side, I get to this point. Similarly, this distance is 2, again 90-degree angle, and then perpendicular distance 2 on the other side will end up here. So this is your triangle after you have done the reflection in x equals to 2. And the next part is you have to do a 180-degree rotation about the origin 0, 0. So now to do the 180-degree rotation, I will connect this point to my center of rotation, which is 0, 0. 180-degree rotation means in this direction, I will go the same distance, which is 2. So I'll go distance of 2 further down, and I will end up here. So this will be mapped onto this. Similarly, this has a distance of 5, and then 180-degree rotation, and then distance of 5, I will end up at this point, which is -5. And then if I connect this line, this point to my center of rotation, and then 180-degree rotation means I have to go in this direction, and I have to go the same distance. So if I go the same distance in the other direction, I will end up here. So this length up till origin and this length from origin up till the image, these two lengths are equal. So this length is equals to this length. So this point will be mapped onto this point here. So now I have all the three vertices of the triangle. I can join them to form my triangle D. So this is your triangle D. So first you applied the reflection, then you got this triangle, then you applied the rotation, and you got the triangle D. So that's how you will solve this part. So this was the last question. This is the end of paper 2 variant 2 for May June 2020.